In this video, we're gonna talk about the vectors and the geometry of space. So let's first discuss the topic that we're gonna study in this handout. It's gonna be the three-dimensional coordinate system, and it's gonna be about the vector. So you're going to have the three-dimensional coordinate system, and we're going to discuss about the vector. And the important thing is going to be about the dot and the cross product that we shall use in order to study the equation of line and the plane. So I'm going to divide the lecture into about 3 parts. So it's going to be about this one that is going to be like a foundation for studying the vector in calculus 2, and the second one that we're going to discuss is going to be about the dot and the cross product. And the most important part that is going to turn out to be several lecture is turn out to be the equation of lines and plane. So we're going to cover this one first, and we're going to cover this one in the second clip. And the later clips is going to be about the equation of line and plane. That is going to be several lecture on this guy. Okay, so the first thing that I'd like you to notice in this picture is going to be, in order to talk about the three-dimensional space, the three-dimensional space consists of like you have the x-axis, the y-axis, and the z-axis. So it's going to be x-axis, y-axis, and the z-axis here. Okay, and this xy plane that you used to study in calculus 1 turned out to be the two-dimensional thing. So it's gonna turn out to be something like in calculus 1 that you used to have the x and the y. So this one is going to be two-dimensional that we already cover in calculus 1. So in calculus 2, we're gonna cover like the three-dimensional space, and it's gonna turn out to be the function with more than one variable. So it's gonna be two variable, and it's gonna be study the calculus of several variables instead. So the first part of the course turned out to be about the geometry, and the geometry that we're gonna study turned out to be the geometry in three-dimensional space. So this one is in two-dimensional, and this guy is going to be three-dimensional, so it's going to be 3D. And you see that you have your x, your y, and your z. Okay, so you're going to have xy plane, xz plane, and yz plane. Okay, that involve the axis xy, the axis xz, and the axis yz. Okay, and you can imagine the XYZ as a corner of a room, and you're gonna have the XY turn out to be the floor. Okay, so you have the floor that is gonna be your XY plane, and if I say on the floor, it's gonna be on your like a XY coordinate, and it's gonna be the value of the function that is gonna live on the z-axis, okay? And this x-z plane is going to be the left wall and the right wall respectively. In order to locate the point in three-dimensional, so we're gonna have like the coordinate system as well. So it's gonna be the system that you have x, y, and z coordinate. So you see that it's gonna turn out to be triple. It's going to consist of 3 numbers. So it's going to be x, y, and z. So for these 3 numbers, it's going to give you the location on the x-axis, on the y-axis, and on the z-axis respectively. So when you see that you have A, B, and C, it means that you're gonna have A unit in X, B unit in Y, and C unit in Z. Okay, so you're gonna have like the location P, A, B, Z. For example, if you like to find the location of -4, 3, -5, you are looking for 4 units on the negative side of x. The negative side of x turn out to be the opposite of the positive side, and the positive side of x turn out to be that we have x, y, and z in the like a counterclockwise way. So you have x here, y here, and you're gonna have z on top. This one is gonna be counterclockwise. So you have positive side, and positive side of x, y, and z respectively. And the opposite of positive turn out to be the negative side. So you're gonna have -4 of x, 3 units in y, so it's going to be in this direction, and it's going to be -5 unit in z. That is going to turn out to be under the floor. So you're going to have the location for 4, 3, -4, 3, and 5. And similarly, if you like to find the location of 3, -2, and -6, it's turned out to be this point. And the box is going to be just the guideline. The thing that you have here is going to be just the point 3, -2, and 6. And the notation that we also use is going to be the Cartesian product, R times R times R. So before we may use the notation R2, R2 is going to be just R times R. So it's going to be just the XY coordinate. However, if you have the triple, it's going to be 3 X, Y, and Z. So it's going to be 3 components. Okay, so you're going to have the first component, the second component, and the third component. So each guy here is going to call component. Okay, so it's going to be the first component, the second component, and the third component, and all of them consist of one triple, and it's going to give us the thing that called three-dimensional rectangular coordinate system. Okay, and the notation that we also use is going to be R3. Okay, so it's going to be X, Y, and Z. The next one is going to be about the surface in R3. The surface in R3 that I like to introduce to you is going to be the constant surface first. The constant surface is going to be z equal to -3. When we are discussing about z equal to -3, it's going to be just a piece of paper that you can see here. And it's going to be like a constant that parallel to the xy plane. So you see the idea that it's going to be the plane that parallel with the floor. So it's going to give you a constant plane. Okay, so this guy is a constant plane. Okay, and it's going to be another, so it's going to be z equal to 3. So it means that it's going to be 3 units above the floor. Okay. The second one is the plane y equal to 5. When you are discussing the plane in three-dimensional, you have the plane y equal to 5, which turned out to be the plane that parallel with the exact plane, and it's going to be 5 units on the y-axis, as you can see. However, we used to have the line y equal to 5 in calculus 1. It's going to give you a constant line. So the constant line is turned out to be just y equal to 5. So it's going to just give you a horizontal line. So you see that we can consider y equal to 5 in 2 ways. The first one is going to be in three-dimensional, which is going to give you what is called the plane. And the second one is going to give you the line. Okay, so this one is going to be in two-dimensional. Okay, so that is going to be like a two kinds of story. However, in calculus 2, most of the time that we are doing is going to turn out to be in three-dimensional. So it's y equal to 5 turn out to be plane that parallel to the exact plane. Another one is going to be the cylinder. So you have x squared plus y squared equal to 1. If you recall in calculus 1, you used to sketch the graph of x squared y squared. Okay, so it's going to be x squared plus y squared equal to 1. So for this guy, it's going to be your y, your x, and you have 1, 1, negative 1, negative 1. And this one is going to be a unit circle that has radius equal to 1. The center is at the origin, okay? However, if you are discussing about three-dimensional, you see that Z can be anything. When you have Z can be anything, it's gonna turn out that you can have Z vary. The way to vary Z is gonna give you the whole cylinder. And the cross section here turn out to be your circle x squared plus y squared equal to 1. Okay, so this guy is your x squared plus y squared equal to 1. So this one and this one is going to be just your circle x squared plus y squared equal to 1. And it's going to be just the circle that you have. Okay, so you see that I throw my paper into a cylinder like this one, and you see the cross section here is turned out to be the circle x squared plus y squared equal to 1. So you're gonna put it this way, so you're gonna see that it's gonna give you the cylinder, okay? And that is gonna be the height that can be varied. Okay, so that is going to be some kind of the surface. So this thing is called the surfaces in three-dimensional. Okay, so this one is called the surface in three-dimensional. The next one is going to be about the distance formula. When we have 2 points in three-dimensional, the next thing that we like to find is going to be about, we like to find the distance between these 2 points, P1 and P2. If you have P1 given by x1, y1, and z1, and P2 given by x2, y2, and z2, Pythagorean theorem that you see that you have right triangle, many right triangle, and the whole important thing turned out to be this right triangle. So you'll be able to prove that this side P1, P2 will be given by square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. So this guy coming from the thing that called Pythagorean theorem. Okay, and this one indicate in the picture for you. So let me give you one example on this stuff. So the distance from the point P equal to 2 negative 17 to the point Q 1 negative 35 is equal to what? So the distance between P and Q will turn out to be square root 1 minus 2 square, and you have negative 3 minus 1 square plus 5 minus 7 square. Okay, and you see that this guy turned out to be 1 square plus negative 2 square plus 5, so it's going to be negative 2 square as well. And then you see that this one will be 1 plus 4 plus 4. So it's going to be square root 9 equal to 3. So you see that the distance from P to Q turned out to be equal to 3 in this case. The next one is going to be about the equation of the sphere. So you see that if I have a tennis ball like this one is going to be a sphere. The thing that you see that is going to be a center. So you have a center at C, and you have the point on the sphere, which are X, Y, and Z. You like to find the equation of the sphere you know the property of the sphere that any point on the sphere turn out to be like having the equal distance from the center. So you have the center is at H, K, and L. So you know that the distance R will be equal to square root of x minus s square plus y minus k square and plus z minus l square. Okay, so this one will give you r equal to square root of this guy. So this one will be constant r. And then you're gonna take the square both sides. So you have r square equal to x minus h square plus y minus k square plus z minus l square. And this one turn out to be give you the equation of the sphere. Okay, so it's going to give you the equation of the sphere. And let me a little bit box this guy. Okay, the next one that I like to give you is going to be one example. So you have, okay, the radius are equal to 2 and you have the center is at 1, negative 2, 0. Okay, so if you have the center is 1, negative 2, 0, and you have r equal to 2. So in this case, you're gonna have 2 square, okay, equal to x minus 1 square plus y minus 2 square plus z minus 0 square. Okay, so this one will give you 4 equal to x minus 1 square plus y plus 2 square plus z square. Okay, so this one will be the equation of the sphere. This thing is called sphere. The next one that you have is going to be about the equation gives you in the way that you have x squared plus y squared plus z squared plus 4x minus 6y plus 2z minus 2 equal to 0. We like to show that this guy turned out to be equation of the sphere, and we like to find the center and the radius. So for this one, you're gonna put into the standard form. Okay, so we're gonna put into standard form. Okay, so we like to put this guy into the standard form. So you see that I'm gonna group x together with x, y together with y, and z together with z. Okay, so you have x squared, okay, plus 4x, y squared minus 6y, and you have z squared plus 2z equal to 2, okay? And you're gonna add by, okay? So in order to do the complete square, you recall that you must have a square plus 2ab plus b square. This one allows you to write a plus b square. And if you have the minus sign, turn out to be a minus b square. So the thing that you must have is gonna turn out to be something like you have have half of the middle guy square. So you see that this one is double your b. So you see that it's gonna be double your b. So in this case, gonna be, you're gonna have 4 over 2 square, okay? And you're gonna have 6 over 2 square, and you're gonna have 2 over 2 square. Okay, so you're gonna add the same thing to the other side as well, because you like to keep the equation to be the same. So you see that you add by 4 over 2 square, which turn out to be 2 square, and 6 over 2 square, so it's going to be 3 square, and you have 1 square. Okay, so this guy turned out to be x squared plus 4x plus 2. So let me group this one. So it's going to be x plus 2 square, y minus 3 square, and you have z plus 1 square. So it's going to be 2 plus 4 plus 9 plus 1. So this guy become 16, okay? And so you see that the center will be at -2, 3, and -1, okay? And radius equal to square root of 16, and square root of 16 equal to 4. Okay, so this one is how we do this example. Okay. The next thing that I like to cover in this video is going to be about introduction for you to the vector. So I like to introduce the vector to you. So what is the vector? The vector that you see that is going to be the quantity that you have direction. So you see that it's going to consist of direction, and you're going to have the length. Okay, so you're going to have the direction and the length, and it's going to be, if you have u in this direction or you have v in this direction. Let me highlight a little bit. So you see that you have the vector v in this direction. So if you put the negative sign into the in front of v, so it's going to become negative v. Negative v is going to give you the same length, however the opposite direction. So the negative sign affect on the direction. So this one is going to be opposite direction. Okay, so if you have negative v, it's gonna turn out to be the vector that has the same length as v. However, it's gonna turn out to be in the opposite direction of the vector v. The next one that you can see, so let me erase this one a little bit. I need some space. So this one is opposite direction. The next one is going to be about the vector 2v. So you see that it's going to be double of your v in this case. So 2v here is going to be double of the length. Okay, and you see that because of the factor 2 turn out to be positive. When you multiply the vector with the positive number, turn out to give you same direction. Okay, so it's going to turn out to be same direction. However, the length is double. And you see that you have 1.5v. So the same idea applies. So it's going to be just half of the length, and you're going to have the same direction. Okay, so it's going to be half of the length and same direction. So this one is called scalar multiplication. Okay, so this thing is called scalar multiplication of V, or multiple of V. Okay, so it's going to be scalar multiple of V. The next thing that we can do with two vectors turn out to be we can add between two vectors. So if you like to find the sum between the vector u and vector v, we can use two laws in this case. We can use the triangle law. So when you see your vector, you see that it's gonna be the initial point. So this guy is the initial point. And you're gonna have the terminal point. Okay, so you have the initial point and you have the terminal point. So the vector, let's say u that you have here, okay, it's gonna be the initial point and terminal point in order to indicate the direction of the vector. Okay, so it's going to be use this guy to indicate the direction of the vector. So you like to add between two vectors u and v. So it's going to be, you can use triangle law. Triangle law is going to be, you're going to write the vector u and the vector v in a consecutive way of the initial point, terminal point, initial point, and terminal point. So you write this one consecutively, and then you draw a close triangle from the initial point of u to the terminal point of v. You're going to have the result vector. So it's going to be the vector u plus v. In a similar manner, if you would like to find the sum between two vectors in the way that you like to use the thing that called parallelogram law. So you use the vector u and vector v that you have the initial point are the same point. Okay, so you have the point, initial point of u and initial point of v are the same, and you're gonna draw a parallelogram from these two vectors. So you have the parallelogram from this u and v, and the diagonal from the initial point. Okay, the diagonal, I have to say the direction. So it's going to be the diagonal from the initial point turn out to be the vector u plus v, and the u plus v turn out to be equal to v plus u. The thing that you see here, we have two kinds of the way that we gonna have to write the vector. So you use the letter u together with some kind of arrow. Okay, so this guy is gonna be arrow in order to indicate that your quantity turned out to be vector. Another way that you can use is gonna be you use boldface. Okay, so you can use boldface. Okay, so you can use bold typeface in order to know, or in order to say that you are talking or discussing about the vector u. Okay, so this one is going to be the way that we're going to write vectors in this course. I can write in the vector way, in the arrow way, or in the boldface way. We be able to find the difference between two vectors by just you have vector u and vector v, and if you want to have u minus v, so you basically just opposite of the v first. So you have v here, so you like to have negative v, so it's going to be the opposite direction, and you just sum u and negative v up. So this guy turned out to be just u plus negative v, okay, by using the parallelogram law. Or you gonna just have u minus v. However, it's going to be just like a u plus negative v, so it's nothing much to explain basically. So it's going to be just you add you have u and you add by the opposite of the vector v. That's all. Another important thing is going to be about the coordinate vector. The coordinate vector is going to be the vector that we're going to have in the rectangular way, that you have two-dimensional, which is x and y, or three-dimensional, which is x, y, and z. So it's going to be the directional vector. So you see that it's going to be the vector that you have the initial point at the origin. So you have the initial point at the origin, and you have the terminal point at the given point A1, A2, or A1, A2, A3. So this one is your terminal point. Okay, and the initial point turned out to be the origin. Okay, so you have this guy, and you're gonna have the vector A, like this called the coordinate vector. So the vector A gonna be A1, A2, and the vector A here is gonna be A1, A2, A3. So this, we use a little bit different parentheses. So this one is called parentheses, right? Okay, so it's gonna be parentheses. However, this one we use the thing that called angle parenthesis. Okay, so it's going to be angle parenthesis to indicate that this one is point. Okay, so this one is vector. Okay, so we like to distinguish between point and vector, and that's why we use different kinds of parentheses. One is going to be angle, is another one is going to be just the normal curly parentheses. Okay, the next one that you mostly use in calculus or in physics is going to be position vector. The vector A that we studied before is going to be, can give you the point or can give you the thing that called position vector. So you see that this one can be called point A1, A2, A3, and this one cannot to be the same as the vector A1, A2, A3. Okay, so this one is called position vector. Position vector will be the vector that has the terminal point at the position A1, A2, A3, and the initial at the origin. Okay, so that is the position vector. And this one will be the vector A or vector OP. And you see that if you move this one, or if you move the initial to X, Y, Z, okay, so you'll be able to move the initial to X, Y, Z, and this guy can be moved to X plus A1, Y plus A2, and Z plus AT. So if you have AB arbitrary point x1, y1, z1, and x2, y2, z2, you'll be able to find the vector A or the vector that represent AB. Okay, so this one is going to be AB. When you write something like this, it's going to be, you're going to have the initial at A. So this one gives you initial, and B will be terminal. Okay, so it's going to be initial. So this guy will be AB. Okay, so this one will be the vector AB, and the way to find the vector AB will be just you're gonna have the terminal subtract initial. Okay, so you have terminal subtract initial. So it's going to be x1 minus y1, y2 minus y1, and z2 minus z1. The next one is going to be about the magnitude or the length of vector. So if you like to find the length, okay, so if you like to find the length, so you basically apply the distance between 2 points. Okay, so you see that it's going to be the distance from this point to this point. So the length given by square root a1 square plus a2 square for sure. Okay, and similarly for this guy, so it's going to be the distance in 3-dimensional. So it's going to be length equal to square root a1 square, a2 square, a3 square. Okay, so it's gonna turn out to be these 3 components. Okay, so this one will be just the length of vector, and the notation that we use for the length of vector turn out to be just absolute value. Okay, so it's gonna be just use the absolute value psi in order to indicate the length of vector A. Okay, so this I use the same notation as in your textbook, so you're not going to be confused. However, some textbooks gonna be, okay, so some other textbook, okay, other textbook can be written in the way that you have A like this. So they use double bar. Okay, so they use double bar instead of 1 bar absolute value in order to indicate the magnitude or the length of your vector A. Okay, and you be able to find the add, you find the sum or the scalar multiplication of 2 vectors. So if you have the vector a1, a2, a3, you like to add it with the vector b1, b2, b3. Basically, you're gonna just add the first component together, second component together, and third component together. Okay, so it's gonna be the green guy together, the yellow guy together, and the pink guy together, and that's all. Okay, another one will be if you like to multiply the vector with the scalar c. So you see that this one will be just you're gonna multiply c to each component. So you see that you get the green, the yellow, and the pink one. Okay, and the c here is called scalar. Okay, or basically it's going to be just real number. And you gonna have the vector. Okay, we're gonna have 3 vectors that play a special role. So it's gonna be vector that is gonna be the coordinate vector on the x-axis, on the y-axis, and on the z-axis respectively. So it's gonna be vector I, vector j, and vector k. So vector I, vector j, and vector k. Okay, so you have vector I give you in this form, vector j and vector k. Okay, so it's going to be 3 vectors that are important. Okay, so you have 3 vectors on each coordinate. It's going to be a unit vector. So this one is a unit vector. It's going to be the length of them equal to 1. So when you have length of them equal to 1, you can use them as the representation of like how we measure the vector on each axis. So this one is going to be 1 unit in x, 2 unit in x, 3 unit in x respectively, something like that. And for any vector A, you're gonna be able to write this guy as A1i, A2j, and it's gonna be A3k. So it's gonna be A1 unit in x, A2 unit in y, and A3 unit in z. Okay, so when you sum them up, you would get the vector A1, A2, A3. So the way to write down the vector, we have two kinds of notation so far. The first way is gonna be you have in terms of angle bracket A1, A2, A3, okay? And the second one turned out to be in the way that you have for A1i, A2j, A3k, okay? So that is gonna be the way that we have two vectors, not the way, two different way that we represent two vector, the vector A, okay? So it's two ways to represent the vector A. Last thing that I like to cover is gonna be because the vector of length 1 turned out to be important in measuring the behavior of the vector. So we're gonna have a special name for it. It's called unit vector. So unit vector is going to be the vector whose length is equal to 1. And if you have the vector A not equal to the 0 vector, so the boldface here, this guy is called the 0 vector. And this one will be just 0, 0, 0, like this. Okay. So the unit vector in the same direction as A. So you're gonna have vector A and you have the unit vector U in the same direction. Okay, so this one is your A. It's turned out to be A over the norm of A. When you have A over the norm of A, it's gonna like normalize. So this one is called normalize. So it's going to be normalize the length of the vector from norm of A to the vector that had the length equal to 1. Okay, so that is going to produce the unit vector. Okay, so let's finish by doing some calculation here. So you have A equal to 403, B equal to negative 215. We like to find norm A. Okay, so it's gonna be norm A. So this guy will be square root 4 square plus 0 square plus 3 square. So it's gonna be square root 25. So it's gonna be 5. Okay. And we like to find A plus B. A plus B. So it's going to be 4 plus negative 2, 0 plus 1, 3 plus 5. So it's going to be 2, 1, 8. Okay. And it's going to be A minus B. So it's going to be 4 minus minus 2, 0 minus 1, 3 minus 5. So it's going to be 6, negative 1, negative 2. Okay. And it's going to be 3b, 3b. So it's going to be just 3 multiplied with negative 2, 1, 5. So it's going to be negative 6, 3, and 15. Okay. The next one is going to be 2a plus 5b. 2a plus 5b. I'm not gonna show this one for you. However, I'm gonna give you the solution that is gonna be negative 2, 5, and 31. Okay, so please do this one on your own. It's not that hard to do. And finally, we like to find the unit vector in the direction of A. So for the last one, it's going to be the unit vector U equal to A over the magnitude of A. So for this guy, it's going to be A, which is 403 over 5 that we have found in the first one. So this guy is going to be 4/5, 0, and 3/5. Okay. So this one consists of the basic foundation of the vector that you should know before doing the calculus that we have this semester. And this one is going to be just the thing that we will need for like in order to find the length of vector, in order to find the magnitude of vector, in order to find the sum between two vectors, in order to find the vector that we are looking for from the point. Okay, the next topic that we're gonna cover in the next video is gonna be about the dot product and the cross product that is gonna be used in order to find the equation of line and plane that we're gonna study next. Okay, so I think that is for this trip.